All right, guys, we are on to series circuits. We'll do series this week, parallel next week. Hopefully do it in a way that you guys can get stuff done and not stress about it. So again, a series circuit, we talked about it last chapter with capacitors. So these are examples, two examples of a series circuit, a very simple one. This is a battery. Okay, and then there are two resistors, and if you notice, the current will come out of the positive side of the battery, and it will go through the first resistor, and then it will go through the second resistor, and then it will return back to the battery. Okay, so in these problems, we're using Ohm's law, which is V equals IR, Joule's law, which is PIV, P equals IV, or I squared R, and then try to figure out what's going on in these circuits. Okay, so these are pretty simple, straightforward examples. The second page of this has 3 problems, which will be your work for the week. It's not so bad. You guys can handle it. Okay, so in this example, we have a 12-volt battery connected to a 3 ohm resistor and a 6 ohm resistor in series. Okay, the first part, they want you to find the equivalent resistance of the circuit. Okay, so if you remember, in a series circuit, the resistance adds. So it would be 3 plus 6, so your equivalent resistance would be 9 ohms. Okay, then you can use that with the total potential of the circuit, which is 12 volts, to figure out other stuff like current. Okay, so that would be B. They want you to find the total current. So if you come down here, we have V equals IR. They solved it for I because we want current. Notice they're using this little E here. That's kind of a shorthand for potential of a battery. Okay, so I equals V over R. Notice they're using 12 over 9. So my current through the circuit is 1.3 amps. Because it is in series, each resistor gets 1.3 amps. Okay, if it was in parallel, that would be the total of the circuit and it would all add to that. Okay, so C wants you to find the power dissipated across resistor 1. So just this resistor right here. There are a bunch of different power formulas, P equals IV, I squared R, all sorts of different things. Hang on, dog's bark. That's exactly why I'm teaching outside today, because she will not stop bothering me inside. But of course, we have to go outside. All right, so the power equation we're going to use here is P equals I squared R, because I know what the current is and I know what the resistance is. You can do it a different way, totally fine. So we're substituting in 1.3 amps squared times 3. You get 5.1 watts, capital W, for power. Okay, and then they want you to find the voltage across R2. Now, this is a series circuit, so the voltage across both resistors will add up to be 12. Okay, so if you notice here, we're using V equals IR, and notice how they label 2 and 2. So I'm using the voltage for 2 and the resistance for 2. Technically, you could label I 2 as well, but because it's a series circuit, the current is the same through each resistor. All right, so just substituting in 8 volts. Pretty simple, pretty straightforward. If you wanted to find the voltage across the first resistor, you could just subtract 12 minus 8, which leaves us 4 volts left. Okay, the second one down here, or I should say the first one, same kind of circuit, different numbers. Okay, again, we're in series, so to find the equivalent resistance, we're adding the resistors together to get a total of 15 ohms. There should be an ohm right here. B is asking for the same thing. We have different numbers, so we're using I equals V over R. So 10 divided by 15. So my current through the whole circuit is 0.67 amps. Okay. They want the power across resistor 1. Same situation here. And then they want potential across resistor 2. Okay. And again, if you want to find the potential across resistor 1, we just take the total and subtract. Okay. All right, down here a little bit further, we have another circuit, same deal. However, they're giving you different quantities. Okay, they don't give you the potential of the whole circuit. Okay, they give you the potential of this resistor, and they give you the current of the whole circuit, and they give you the resistance of that. Okay, so now you have to use that information to work your way backwards. So they want the resistance across R1. Okay, so we're using Ohm's law here, V equals IR. Notice how everything is labeled. We're just substituting in 2 times 4 is 8. Hang on. Dog again. People walking in my neighborhood. Okay, so that is how you got the voltage across resistor 1. Okay? If you notice, D wants the total potential of the entire circuit. The dog is killing me today. All right, so back to reality after the dog barks and barks and barks. Here we go. All right, so if you notice, we know what the potential is across this resistor. We know what the potential is across the other resistor. If you add them together, you get the magical answer for D. Notice they did it a different way. So if you notice, there's about 1,000 different ways you can do these problems, and that's totally okay. All right, so then the second question says, what is the resistance of R2? All right, I know what the current is, and I know what the potential is because I can subtract. Or no, because they give it to me, so then I just subtract. So again, V equals IR solved for R. Things are labeled. We get resistance is 2.5 ohms. Okay. C asks what the power dissipated is in the entire circuit. So the numbers that you're using here have to be for the entire circuit. So if you notice here, they're using current because that's the same in a series circuit. And then they have to solve for the equivalent resistance of these two resistors, which you just add them together. So you end up with 26 watts of power. Okay. D, they did this way, but we had already talked about it with A. The remaining 3 problems on the other sheet of this worksheet is your homework for this week, assignment number 1. All right, miss you guys. Hang in there. I will do everything I can to be at graduation. Should not be a problem since, I have nothing else to do. I hope you guys are hanging in there. Just try to stay positive. It's almost over.